And for doing regression analysis, do we need this street?
No,
Will it be not required, right? Just delete this. Okay. Do we need this LA, whatever is there? Anyway, we have huge amount of not NA means not available. This variable is not available. So do we need this?
no.
No, right? So we don't need this. Similarly, these things are not required for the analysis. House style, maybe 2-story, 1-story, that is not required. So what can be required from here? Okay. So maybe this data looks like bearing. Okay. MS subclassification. So this looks like bearing and regression analysis. Please make a note of it. Regression analysis can be used, okay, only for I'm just taking this data and only for continuous data. Okay, Control C, and I will be opening it in a new file. Okay, regression analysis can be done only for continuous data. Control V. Okay, now I am going to do whatever is not required. I will not be having that. Okay, so this joining MS join something like that is there. It's not required. Let us remove that. Lot frontier, some continuous data is there or some data is there. We'll have it. Lot area is required. The street is not required. Let's delete that. Let's delete this. This is not required for understanding the prediction of housing price. Okay, delete. This is not required. This is not required. Okay, so from here to here, I think till here. Sorry. Okay. So from here to here. Okay, these things are not required. Okay, delete. This column is not required. Delete it. So whatever is not required, just delete that. Okay, delete, delete, delete. This is not required. Delete. Okay, this is also not required. Overall quality. Okay, we can just take that. We'll see overall condition. We can take that year built. Okay, so that means year built. So this is just take the year built when it was built. Okay, so when it was built, and currently we are in 2026. Okay, so can we find out the age of the building? Can we find out age of the building?
Yes, ma'am.
Yes, so this will be equal to 2026 minus, that is the current year, minus the given year. Okay, so age of the building is also a factor to decide its price. Okay, a very old building is there, so this can also be considered. Okay, so this variable you are creating. Okay, this variable you have created. Okay, so year of something information is given. We have to check what kind of information is it. If required, we can just see. Okay, so this is also not required. Just delete those things. Okay, although they are going to give us some information right now, not required. Okay, delete it. Okay, then what is this? Somewhere many of the data set is 0, 0, just leave it. We will not be able to, it will not be able to show the variation of y data. Okay, so this also, all the text, these are actually, what are these data? These are actually your categorical data. Okay, so if we have categorical data, we cannot, most of the time we cannot do regression analysis. We need continuous data. Okay, so this is also not required, not required, not required, not required, and we will delete it. Okay, so this is basement, something, some area is there. Okay, we can just take this, and just delete this. No, not requirements, we will not have this. Okay, delete. Okay, then a type of electrical circuit, just a minute. Okay, let it be. So, okay, so year built, this age, this, okay, this may be required. This is again not required. First floor, you can have this one. We'll just check it. Okay, low quality, not required. Delete all the numerical data we are going to take, and the rest of the variable will delete. So many things are there. Okay, so what we can do here, I'm just going to delete the rest of the variable. Okay, the rest of the variable. Okay, from here to here. Okay, all of them I'm going to delete. Okay. Okay, now we have some, this is also not required, garage type, something like that. So this is also not required, delete it. So whatever is required, whatever the continuous data we have, we'll just take that. Is this clear to all of you till here? So whatever is there, we'll just see, type. Is it giving any information about our y value? It's not giving, right, much information about the y value. So we'll not have that. Okay, garage, something, year built up, that is not required. Okay, garage area, it may give us some information. Okay, so basement, all these things are not required that much. How many bedroom? Information about the bedroom we can get from the total area. Okay, these are not required. Okay, now whatever required for our multiple linear regression analysis, what we can do, this ID is also not required. Out of this, the sales price is what? Sales price is what? Dependent variable. Okay, yes, Neil, are you there?
Yes, ma'am.
Yeah, so y, this is our y value. Okay, this is our y value, and we're just coloring it with some color just to have an identification. So this will be our overall data set. Okay, this is going to be our overall data set. Okay, so this is going to be our overall data set. Now, if we have too much of NA value, let's say if it is less than 10%, okay, we can, it's a numerical data. If it is categorical data, we have to impute it with mode of the data. Okay, if it is numerical data, we can impute it with the mean of the data. Okay, so let's count how many NA values are there. Let's count how many NA values are there. So equal to count if. Okay, so from here to here, only here we have the NA values. Okay. Okay, so here, and within bracket, we'll just write NA. Okay, capital N A. That's it. Okay, let's count it. So 259 NA values are there. And how many total data set is there? 1460. Okay, 1460. Why? Because the first is the header one. So the percentage of NA values will be equal to, percentage of NA value will be equal to this divided by 1460. 1460. Okay, 17%. If required, what we can do, wherever NA values are there, we can replace it by the mean value. So let's find out the mean of the data. So equal to average of all this data. Okay. So instead of B1, we'll have it till B2. Is this clear?
Yes, ma'am.
Yes. So 70.04. Okay, 70.05. We can just take the round of value. 70.05 is the average value. So whatever what we are going to do, wherever we have the NA value, okay, wherever we have the NA value, okay, in this column. Actually, nowhere else NA value is there. Only in this column we have the NA value. We are going to replace it with 70.05. That's it. If at all you have to do, replace all. Okay. So right now we have this all 260, something around 259, right? So maybe somewhere one more NA value is there. So that is equal to 260 replacement have been done. Click OK. Close. Okay. So see here 70.05, 70.05. So this can also be helpful in our multiple linear regression analysis. Okay. So now we have multiple things are there. Okay. Multiple things are there. So we are going to multiple variables are there. Why multiple linear regression analysis? Because multiple variables are there. So what are the multiple variables? So first one is this garage area. Maybe if garage area is high, price will be more. Garage living area, some this information is there. So this can be your x1 variable, x2 variable, x3 variable, x4 variable, x5 variable, x6 variable, x7 variable, x8 variable. Okay. Like that we have some multiple variables are there. So from all of them also, most of the things will not be required. Okay. So if we have the information from here also, why to make the model so complex? Okay. Why to make the model so complex? So what can be done from here? First thing what you can do here is go to data. Okay. Go to data analysis and just see the correlation. Just see the correlation. It's taking some time. Okay. So from here, we'll just take the correlation, click on OK. And what is your input range? So input range will be all this data. Okay. Just select everything. Till here. Okay. Enter. So this is our labels are there in the first rows. Okay. And where we want our output to be. So let's take the output somewhere here. Okay. Click on OK. Click OK. And then you have this. Just see with this information, we are just trying to see with the Y variable. Y variable is what? Sales price. Okay. So Y variable is sales price. This one. Okay. So we can just have a color for it. Okay, so see here, somewhere we have negative correlation. So sales price with this MS subclass, okay, we don't have good amount of correlation. So this is not required. Again, drop the column. Okay, which column we are going to drop? So first is Control C, this column we are going to drop because the amount of correlation between sales price and MS subclass is not good. Okay, so that's why we can keep this column. The second one is second information about lot frontage. So we will keep these things. Okay, we are going to keep this. This also will keep. It has good correlation with overall quality. See, 0.79 is there. So it has to be kept. Okay, with this overall condition, it doesn't have good correlation. 0.07. It doesn't have good correlation. So we are going to omit it. Okay. Built up area. Okay, built up area. So see here, if the age is both of them have same kind of relationship. Okay, but instead of using just the year built, okay, year built, we are going to use it as the age of the building. Okay, if more age, that means more age of the building means less price may be there. Okay, because the quality of the building is going to decrease. That's the reason they have negative correlation. Okay, so this age compulsory we are going to use, and then we have 0 point basement. Some SF1 is there. So second one is also there. Third one also correlation. So where whatever we are going to select that variable where we have greater than, we are just taking a threshold value where we have greater than 0.3. Okay, 0.3 correlation. So we can just take lot frontage. We can take overall quality. We can take age. Okay, so I'm just coloring it age or Control Z. Instead of this, we are going to color whatever is required. Okay, this age is there, overall quality. Okay, and then we have basement. We'll just take this also. First, we have something. Okay, so this information we'll take wherever it has good correlation with sales price. Okay, this is also there. Is this fine? So what we are going to do, just copy paste Control A. So everything, Control C, and we are going to paste it in the second one. Sorry. We are going to paste it in the second one. Okay, because first one was our raw data. Okay, this is renamed. It was our raw data. And even here also we have done some kind of cleaning of the data. So yeah, raw data. Now what is required? Just see here, this one, copy and paste it somewhere here. There's a number. Okay, again delete both of them. These two things are not required. Delete. Okay, and overall condition. One insert just one where we can put this. We can just paste it here. Is this fine? Okay, then first column is not required. So first column is not required. Okay, then what else is not required? Lot area is not required. Lot area does not have good. 0.26 is there. Let's take this also. Okay. Overall quality, overall condition. Lot area is not required. Okay. Just delete. Overall condition is not required. Delete. Age of the building is required. We must be having that. Year built, age of the building. And after that, everything else is required. Okay. Now we have the data set with us. Okay. So we have the data set with us, and this is our Y value, and rest of the things are our X data, independent variable. So how many independent variables we have? How many independent variables we have? Yes, all of you please turn on your video. Yes, how many independent variables we have? Just count them and write it in the chat box. How many independent variables we have? Write it in the chat box. Write it in the chat box. Okay. In raw data only we did the changes. Okay, let it be. Control copy, and we are going to paste it to end. Okay, this was okay. In raw data only we did the changes. Okay, let it be. Control copy. In second second sheet. Okay, this was okay. In raw data only we did the changes. Okay, let it be. Control copy, and we are going to paste it to a new tab. Now you tell me how many independent variables we have. Quickly. How many independent variables we have? Okay, so if you cannot, Okay, let me see. 8. Ritesh says 8. So this is the first independent variable 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So when we were having just simple linear regression analysis, what was the equation for y variable? Sorry, y cap. That means y predicted value. It was equal to what? Subarawat? It was equal to what? For simple linear regression analysis, what was the equation?
Then I can't answer it.
Anyone else? Just let me know. Neil, can you tell me?
I'm not sure either.
Okay. So it was done in last class, right? Mohammad Umar Abjal? Mohammad Umar Abjal?
Yes, ma'am.
Yes.
Ma'am, I think real value minus predicted value.
What was the equation? How you have calculated y predicted value?
Oh, how you have to find y predict?
So equation for y predicted. That's what I'm telling. For simple linear regression analysis, what was the equation for y predicted? Y predicted is equal to beta naught. After that, yes, Rajsoni. It is equal to beta naught plus beta 1 multiplied by x1. Simple linear regression means only one x variable will be there. Okay. When we have only one. Okay. When we have multiple linear regression analysis. Okay. Now you know that we have 8 variables. Okay. 8 independent variables are there. So please write it in your notebook. Y predicted will be equal to beta naught. Of course, we will be having plus beta 1 multiplied by x1 plus beta 2 multiplied by x2 plus beta 3 multiplied by x3 plus beta 4 multiplied by x4 plus beta 5 multiplied by x5 plus beta 6 multiplied by x6 plus beta 7 multiplied by x8, x7, and finally plus beta 8 multiplied by x8. Is this possible for us to do the calculation manually? It's not possible, right? We cannot do the calculation manually. It is possible, but it will take a lot of time. So why to waste so much of time in this? Okay. So what we are going to do? I hope you have written this equation. Have you written this equation in your notebook? This equation have you written? Yasina, have you written?
Yes, ma'am, I have.
Okay, good. Tarusi, have you written? Okay, Tarusi is not there. Okay. So whatever. Maybe I hope you have written. Okay. So I'm just deleting it and trying to get all the beta values. So least square regression analysis is used. So now since we have 9 unknown terms, beta naught was one of them, and all the beta I, that means beta 1, beta 2, beta 3, up to beta 8. So 9 equations will be there. Solving those 9 equations, we will be getting all the values of beta and all the values of beta naught, for which the error term will be minimum. Okay. Let's go ahead and do the multiple regression analysis. So what we are going to do, we'll just go to data. Where is this data? Go to data. Okay. Click on data analysis and go to regression. I hope you have done the correlation analysis, then regression. What is our y value? This is our y value. Okay. I have selected all of them. What is our x range? So our x range is all these values. Okay. Let's do one thing. One more time for just a minute. Okay. We'll include the labels also. Okay. We are including the labels also. Then what is our input x variable? So from here to this is there, 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 this is there. Okay. Control Shift Enter. So all of them have been selected. Enter. Okay. Now what we need, everything we need. Okay. All this information we need. Where we want our output range, confidence interval, by default we'll keep it as 95%. For this kind of analysis, 95% is okay. And then click here, click on enter. Okay. And click OK. Input range must be a continuous reference. Okay. Click on OK. Okay. So what has been done? This has not been taken properly. Just a moment. Okay. Just a moment. This y value was not, sorry, x value was not selected properly. Okay. Let us select it once again. Just see that you are not selecting y value. Whatever is not in color, that is our x value. Okay. Till here we have selected all of them. Enter. Okay. Click on OK. You will see within a time we will be able to do. And for one more thing, you have to remember, whenever we are doing multiple linear regression analysis, okay, this is multiple linear regression analysis, we must be taking into consideration this adjusted R square value. Is this clear? Okay, so this adjusted R square value. Now everything has been given. Let us see that. Okay, let's see that. Okay, so now we have, you can see intercept. Intercept means this is our beta naught. Okay, this is our beta 1. Okay, lot frontage, overall quality, everything has been there. Okay, and this is all the information. This is the predicted value. This is the predicted value, residual value, and then standard residual. Everything is given to us. Okay, and all the plots are also given. I think somewhere the plots will be given to us. Okay, we have included or we have not included. We'll see. Okay, whatever. Maybe are also given. I think somewhere the plots will be given to us. Okay, we have included. Whatever, maybe we'll see if we have included. This is our SSR. I hope you remember for SSR, if it is simple linear regression analysis, just go back and check in your data. This value will be just 1. Okay, this value will be just 1. And total we have 1459 observation. Out of 1459 observation, residual will be 459 minus 8. Okay, and actually how this total is coming, it will be equal to n minus 1. How much is n value? N is equal to 1460. 1460 minus 1 is our total value we have. Minus 1, this is for the constant mean of sample data must be equal to mean of the population. So that is the constant minus 8. Why this 8 is there? Because we have 8 variables. From here to here, 8 independent variables are there. For that region, 8 is there. And 1459 minus 8 is the residual. Okay. So that's how it has been taken. You can see that standard error is very, very high. That means there will be, and this adjusted square is also not that good. Okay. So why to have a complicated model? Let's find out some more thing. Okay. Let's find out some more type of scenario. How we can find out more type of scenario? What we are going to do, instead of taking more than 0.3, we will take more than 0.5. Okay. So more than 0.5 is what? Age. Just make a note of it, and you must be telling, okay, more than 8.5, more than 0.5 is what? Age, first one. Overall quality, second. Okay, overall quality, second. And then first, this first floor SF. Okay, so these things are there. We must be taking into consideration this one. Control A, Control C. So this is second scenario. This was first scenario where we have taken, first scenario where we have taken all of them. Okay, now and we got just adjusted R square value of 0.77. We are not satisfied with that, so we'll just take those variables where where the correlation is greater than 0.5. Okay, so this can be lot. That means lot front test has to be deleted. Overall quality we can include. Okay, this age we have to include. This something like basement 0.38. So we should not be including this. Delete it. First floor SF something is there, so that can be included because 0.6 is there. Okay, so 0.6 is there, that can be included. Second floor we have to delete. Okay, now how many variables are there? Given this can be included, this can be included. Now how many variables are there? How many independent variables are there? 5 are there, right? So now again, the same thing we will be doing, the data analysis. So somewhere here we will do, let's go to data. How many of you are okay with this? Please raise your hand. Go to regression, click on OK, our X data, our Y value. Okay, we have selected. Now we have to select our X data. So from here to here. So only 2 people are okay. What about the rest of the students? Are you listening to me or you are not listening to me? Okay, so we have taken all the data set, click on enter. Okay, so this has been included, output file, residual, everything. Where we want our output to be, let's make it here. Okay, or maybe a little bit here. Okay, click on enter, click on OK. Somewhere something is not okay. Okay, let's click on this. Enter. Okay, click on OK. Is this fine? So now also just see why to have a complicated model. There we were having 8 independent variables. Now we can do the same thing just with 5 independent variables also. Is this fine? Just with 5 independent variables also we can do. Adjusted R square is so and so value, and rest of all of them has been given. These are the coefficient: beta 1, beta 2, beta 3, beta 4, beta 5, and beta naught. Okay. Standard error is given to us, and we want to reduce p value. We are taking. Okay. We can see that p value is less. That means we are rejecting the null hypothesis. Rejecting the null hypothesis means null hypothesis is there is no relationship between sales price between dependent variable and the independent variable. We are saying that if it is less than 0.05, that means there is some relationship. Okay. Now with this also we are not satisfied. We want to see a little bit more information. Okay. So control A, or maybe we'll just take the raw data. Okay. Control A, everything. Control C. This was the second scenario. In seat 4, we were having the second scenario. We'll learn more about it in our machine learning class. But for now, we just learned the second scenario. Okay. Now we have the third scenario. Okay, sorry. We're just renaming it. Third scenario. No, wait. How come just during the class? Okay. Control C, and I'm just pasting it here. Okay. So what we need to do, instead of 0.5, now we will take the correlations where it is more than 0.7. Okay, where it is more than 0.7. So 0.7 this one, and this two. Only this two we have, right? Yes or no? Do you have any other thing? Do you have any other thing? No, I don't know people are there or not. Not responding at all. 0.79 overall quality. Okay, this also is not required. Just with 2 we will see how much is the adjusted R square value. Just with 2 we are looking. Okay, so this is x1, this is our x2 now. Now let's do the analysis. We have data, click on data, go to regression, click on OK, and the y value is this entire thing, enter. Okay, then our x value, this is equal to both of them. We are going to select 1460, right? That's it. Click on OK. I hope done. And then where we want our output to be, maybe somewhere here we want it. Click on OK. Click on OK. Now you see we got the adjusted R square value of 0.71. So that means just with 2. So you can have multiple scenario and you can check which one is giving us more information. So this will be our beta 1. Sorry, this will be our beta naught, beta 1, and beta 2. Okay. So if all of you, so I may give you this information, Control C, Control C, and I have this information for you, Control B. Okay. Let's say overall quality is 6. Okay. And this area is 1320. Okay. What will be the sales price? All of you just see here and tell me what will be the sales price. All of you, 22 students are there in the class. Everyone must be responding. So this type of question I may be giving you. So if you have the test data, so this is how we can check for the test data. Yes, how much is the sales price for this test data? Write your answer to me in the chat box. Yes, sir. 22 students are there. All of you send your answer to me in the chat box directly. Okay. I got answer from one of the student. From Raj Soni, I have received the answer. Rest of the students quickly. Raj Soni, I have received the answer. Rest of the students quickly. You need to share your answer to me quickly. Subharawat, what you are going to do? Asmit Kumar.
Yes, ma'am.
Yeah. What you are going to do with this? Jageshwar Oran. What you are going to do with this? Jageshwar Oran.
Yes, ma'am.
Yeah. What you are going to do with this? Okay. I got answer from Neil also. Good. So just send the answer to me directly. Okay. Good, Neil. Whatever you are going to explain, I'm going to tell the same thing. I'm going to do the same thing here. How did you get the answer?
First I multiply 6, which is overall quotient with coefficient of overall QL, which is 3
That
to
is this value, right? Good,
Yes.
good, good. So
and then I multiply 1320 into Grieve area coefficient 55.86 223,
okay, good.
and then minus the sales price.
Plus intercept for this one. Okay.
Yes,
So this is how I'm sure you have got this answer, right? So 16673.9.8. Okay. So what we have done, so what we did, the equation will be for any test data. Okay. For any test data, the predicted value will be equal to, this will be equal to what? Okay, let me write here. From here I will be writing. Okay. Test data predicted value. Okay. So this will be equal to beta naught plus beta 1 multiplied by x1. Only two variables were there, overall quality and some living area. Okay. Garage living area plus beta 2 multiplied by x2. Okay. So this was our equation. So for this beta naught is how much? Beta naught is this value. Okay. So minus 104093. Okay. Plus beta 1. How much is beta 1? This value 32849.05 multiplied by x1. What is x1? 6. Okay. Plus beta 2. How much is beta 2? 55.86 multiplied by beta 1. How much is beta 1? Sorry, how much is x2? How much is x2? 1320. Okay, 1320. So if you just evaluate this, you will be getting this one. So this will be the predicted sales price for the test data. Okay. Similarly, I'm giving you one more so that you do the calculation. So I may give you this information. Okay, one more quiz question. I may give you this information and I'll ask you to get the value of sales price. Okay. So maybe this is 7 and this is 1000. How much is the sales price? Okay, just calculate that and share your answer to me in the chat box. Okay. So for today, I'll take the attendance through your information from that way, or let me share. Okay, one more class. I thought today we are going to end the session, but you have to tell me